Welcome and thank you for joining. In this lesson, we'll discuss how to prove trigonometric identities. What is a trigonometric identity? Well, it's an equation that contains trigonometric terms to both sides of it, and we want to prove that the left side equals the right side. So, in other words, we want to prove that the left side is identical to the right side. So, obviously, they're not going to look the same. When we're asked to prove an identity, that's because we want to simplify them until they look the same. Now, rule number one to proving trig identities is that we can never take terms from one side of the identity to the other. It doesn't work like in regular equations, even though this is an equation in itself. And rule number two is to prove the identities, we simplify one of the sides and we make it look like the other. So we can pick either side and make it look like the other, or we can simplify each side separately and until we reach a point when the two sides would look identical or the same. Now, proving trig identities is as simple a process as substituting and simplifying. So we substitute various terms so that we have or we can see the presence of the same terms on both sides of identities, and then simplify them until they start looking the same. So because proving trig identities consists of changing terms or replacing terms so that they have same terms on both sides, then we will have to use formulas that will make both sides equivalent. The main formulas we use in proving trig identities are the reciprocal formulas. So cosecant theta is the reciprocal of sine, secant theta is the reciprocal of cosine, and cotan theta is the reciprocal of tan. So these three formulas must be memorized and understood how they work. Now, these are formulas also that we have discussed in the previous unit as well. Quotient formulas are the formulas for the tan and cotan ratio. So tan theta, as you know, is y over x, and tan theta is equal to sine because if you divided both numerator and denominator by r, which is the hypotenuse for an angle on the Cartesian plane, then you see that we have created the sine and the cosine ratios in here. That's why we say that tan is sine over cos. And cotan, being the reciprocal of sine, means that we can flip the fraction or reciprocate. That would be the correct math term to use. Reciprocate sine over cos, and that will give cos over sine, which equals cotan theta. Now, here goes the formula of all the formulas, I would say, so the Pythagorean identities. We call those Pythagorean formulas, and the main formula that we should always memorize is sine squared plus cosine squared equals 1. Now, it is not too difficult. I give this formula 3 stars because it's that important to remember. And I'm not all for memorizing a lot of information. Memorizing is a very important part of learning, but the most important part of learning is connection. So we memorize to the capacity that we can hold in our, memory, but making connections help us understand and solve a lot more problems. It never ends. So long story short, how can I memorize this? So because these are called Pythagorean formulas, you might probably think of it this way. All the Pythagorean formulas are about two squared things that equal 1, right? So remember a squared plus b squared equals c squared, for example. Now, in our case, what we have is the sine squared and the cosine squared, right, together would equal 1. Now, how does that work? Now, the way this works, or the way we have proved it, is by replacing sine by the ratio of y over r, because that's what it equals, basically. So sine is y over r and then squared, and then cosine is x over r and then squared. Now, that will make the term y over r squared, y squared over r squared, and then x squared over r squared. As you can see, these two are two fractions with the same denominator, which means that we can bring them together under the same denominator, r squared And we see that we have y squared plus x squared. And you can see here the r squared, the value of r squared, which is x squared plus y squared. And voila, we have r squared divided by itself equals 1. So we started with the left side in here. We simplified it, and then we got the value of 1. This is the proof for the Pythagorean identity sine squared plus cos squared of an angle equals 1. Now, besides this main formula for Pythagorean identity, which is the Pythagorean formula for primary ratios, we can derive one for the reciprocal. So these two are the Pythagorean identities for the reciprocal ratios. Now, the way this works is very simple. So if you want to prove this, we always start off with sine squared plus cos squared equals 1. And if we decided to divide both sides of this equation by cosine squared, and we can do that. Remember, we're just actually analyzing the formulas. We're not proving identities yet. So cosine squared. Then we'll see that sine squared over cos squared will give tan squared. And cos squared divided by itself would give just 1. And 1 over cosine squared equals secant squared theta. So this will connect tan squared with secant squared. Remember, both tan and secant will have cosine in the denominator. So that's one way of memorizing the connection that exists between them. Now, similarly, you can create a formula for tan squared in here. So this would be one format of the formula, which is basically the same as what we have in here. And another formula that we can choose to remember, and I say choose to remember because we don't have to memorize it. You can quickly derive it whenever you need it. All you need to remember is that there is a connection that exists between them. So write the main formula and then derive the others. So this would be secant squared theta minus 1. So that's another version of the same formula. So the last one is the cotan or the reciprocal of tan formula. And to prove this formula in here, we can simply follow the same process as we did for tan. So we start off with sine squared plus cosine squared, which is equal to 1. But this time, instead of dividing by cosine squared everywhere, we're dividing by sine squared. When you divide by sine squared every term in this equation, then we will get sine squared over sine squared equals 1. And then cos squared over sine squared is cotan squared theta. And 1 over sine squared is cosecant squared theta. One way of memorizing this formula for me that has worked for me is the co-cos will go together. So cotan, cosecant, right? So they're in the same formula. And if you want to know, or if you want to use a formula just for cotan and connect it to the cosecant, then you simply solve this equation for cotan, and that will be cosecant squared theta minus 1. So that's another form of this very formula up here. So again, what formulas do I have to memorize? The one that I always memorize is this one here. So I will know this forever. So I cannot forget this. It's a very important formula in mathematics. Now, when it comes to these two, I can quickly derive them at any time, knowing that I can divide by either cos squared or sine squared both sides, and then I can see the connections. But obviously, while you're working on it in this unit, and as you prepare for the exams, then it is important that we memorize them temporarily at least. Okay, so we're going to move on to proving some identities, and I am going to start with example number 1, not A but B. So here we go. So what we have in this case is the identity cos theta tan theta equals sine theta. So we have to prove that the left side of this identity equals the right side, which is simply one term. Now, in order to prove that the left equals the right, we have to pick one side, we said, and the side that you want to choose to work with would be the side that has more terms, because the more terms you have, the more tools you have in your hands to work with and simplify. So it seems that the left side has more terms, so I am going to work with the left side. So the left side is equal to cosine theta, tan theta. Now, always keep an eye on the other side, but do not stress out right away and think, oh, I'm going to get there. I don't see this term. It doesn't even exist in here. So be patient and always think, what is the one step that I can take in here? And when we talk about steps, we talk about which term can I replace and with what. Now, remember that the formulas, which are on the previous page in here, are not visible, but I would encourage you to actually write down the formulas and keep them handy as you practice. And the more you practice, the more naturally they will get in your head and you will memorize them. But in this case, because I see that we have tan theta, right? So, and the other side doesn't have any of the quotient formulas, then I am going to think of replacing tan theta. So one of the strategies that I use very often is convert everything into sine and cosine. And the reason why is because sine and cosine merge very nicely in this very simple, very easy to remember formula, and then I can simplify the expressions to what I want them to become. So we have cosine and tan, and we decided to let tan go. So cosine theta, let it stay here. We cannot easily replace cosine theta. Well, you know that cos theta is involved with a tan ratio, but that will make it sine over tan. So that's one way. It's not a very common, transformation that we use. And another formula where we see cos theta is when cosine is squared. So cos squared and sine squared together. So, and we don't have a power of 2, so we're going to leave it as is. And tan theta is sine over cosine. And you probably see what is happening right here. So you are multiplying cosine by a fraction of sine over cos, which means that, you can see this, but I'm just adding this little detail just in case. So, which means that if you convert this into fraction, you multiply tops to tops, bottoms to bottoms, or you can simply see that cos theta is a factor in both numerator and denominator, which means that the left side will simplify to simply the sine of theta. And I'm going to write sine theta in here. That is the left side, and I see that is the same as the right side, which means that identity is proved. Now we'll move on to another identity. So we have 1 plus cosine equals sine squared over 1 minus cosine theta. Now, true, we can replace cosine of x with tan and sine, but that is the long way. That's when we are very desperate. We cannot replace a cosine with anything else, and then you decide to go for tan over sine, since they're connected together. Sine and cos are connected by tan. On the right side of the equation, I see sine squared. So that is a signal for me to pick the side. So whenever you see a power, the side that has the power is screaming, pick me, pick me. So we're going to pick the right side. So the right side in here has more terms, as you can see, and more opportunities to simplify and to replace and simplify terms with. So I'm going to start with the right side. And I hope you're okay with this. Okay. So I like to write the right side the way it is. I like to write the terms that I'm working with the way they are, because as you write them, you can probably come up with ideas of, what you have and how to replace them. Now, always keep an eye on the left side. Do not stress out to finding the similarities or to make them identical in one step, because that probably isn't going to happen. So continue working and think, is there anything that I can replace and with what? Now remember, trig identities are as simple as replace terms with using different formulas with whatever they're equal to, and then simplify, replace and simplify, replace and simplify. Okay, so what can we replace in here? Well, I see sine squared, and I know a formula that has a sine squared, and this is sine squared and cos squared, which equals 1. And all I need in here is a sine squared. Okay, wait a second. So I can easily isolate sine squared here, 1 minus cos squared. And trust me, as you practice, this will come so easy to you, and you're gonna substitute right away without thinking too hard. I know that I'm probably over explaining this a little bit right now, but the only purpose of it is so that we understand what is going on in every step. So 1 minus cosine squared in the numerator and denominator. I'm not replacing anything in here because there is not much that I can replace and make it look simpler, because it's going to look probably more complicated. Now, the good news though is that now I have cosine only on the right side, and the left side has cosine only. So, which means that hopefully they will simplify, right? So here we had sine, but we solved this problem, right? So now we are going to think, how can we simplify more in here? And here is another story that I haven't mentioned yet. Trig identities, true, are about trigonometric terms, and we need to know the trigonometry part of solving these problems. But one very very important and integral part of proving trig identities is algebra, because they are algebraic expressions at the end, right? And we have to simplify algebraic expressions, so we need to know our algebra very well. And a part of algebra that we use is very often factoring, so expanding and factoring. So if these formulas need a refresher, please review them again, because we're going to use them. Remember that if we have a squared plus 2ab plus b squared, this will simply be a plus b to the power of 2, or a plus b times a plus b. And if it happened that this sign here was a minus, then you would have a minus instead of a plus. Another important formula, or a special quadratic that we have learned and reviewed since grade 10 and reviewed in grade 11, is a squared minus b squared. We know this is known as the difference of squares, so this would be a plus b and a minus b. So a plus and a minus. So as you can see in here, in our case, we have 1 minus cos squared x, or dare I say 1 squared minus cosine squared x, which is practically same thing as, and again, I know you see this, I'm just making sure that we all understand what's going on. So when you have cosine squared, it means that we have minus cosine of x to the power of 2, right? And then divided by 1 minus cos x. Can we factor now? And you're probably factoring in your head, I hope so. So this would be 1 minus cosine of x multiplied by 1 plus cosine of x. So we use a difference of squares formula, and divide this by 1 minus cosine x. Now, you can probably see that we have a common binomial in both numerator and denominator in the role of a factor. So this is the only thing we have in the denominator, so that's the only factor we can call it. And this is also a factor, so that means they simplify. And the right side of this identity now becomes 1 plus cosine of x, or the right side becomes the same as the left side. So we're going to write that down here, and we'll celebrate it with a yay. Okay, so let's do another one. So in the next example, we have cotan theta over tan theta equals 1 minus sine squared over 1 minus cosine squared. So you've probably already made up your mind and made a decision which side to work with. So either one would be fine in here. I like to use the formula for Pythagorean identities in here, so I'm going to try this first. So I'm going to try the right side and see if it works fine. If it doesn't, then I'll move on to the other side. And this is what proving trig identities is, having fun through the process of replacing and simplifying and trying to see beyond the reason why something is working or something is not working. So 1 minus sine squared over 1 minus cosine squared. And I see that 1 minus sine squared can be simply cosine squared theta. And 1 minus cosine squared is sine squared theta. So that's as far as I can go in here in this case. So I'm thinking, okay, so I have cosine and sine, and I have cotan and tan here. So how do I bring cotan and tan in here? So we have to do this one step at a time. Because we have a power of 2, then we're going to say a power of 2 for cosine means that we have cosine theta multiplied by cosine theta. And sine squared theta is sine of theta multiplied by sine of theta. And then once I do this, I try to recognize any of the fractions, any of the terms, whichever possible that I have on the left side. And as you can see, we have cotan at the top of the fraction. So if you look at the right side, you see that you have cosine theta in here. And we have also sine theta in here. And we're going to say that would be simply equal to cotan theta. So far so good. I'm going to replace that by cotan theta. And the other term that we have in here is cos over sine. Then we're going to think that, wait a second, cosine over sine, isn't that another cotan theta, right? So we basically have cotan times cotan, which could have probably very easily gotten it from here. But I wanted to split these two terms. And now, for a reason, you'll see why. So we are happy having cotan theta right here on top of the fraction. If you want to make it look like a fraction, by all means, go for it. Now, the problem is, how do I bring tan theta in? So we're going to say, well, I like having this cotan theta here. Maybe I can work with this cotan theta, the second one, the blue one, to make it into tan. Wait a second, isn't cotan the reciprocal of tan? So we're going to say, okay, so keep that red cotan on top. And instead of cotan theta over 1, we can write 1 over tan theta, because they are identical, right? So now we're going to say that the right side of this equation then seems to be exactly the same as the left side, because we got cotan theta over tan theta here, which is what we have on the left. So far so good, I hope. We're moving on to the next identity. If you need to better understand how every step worked, so try to pause the video and try to do this on your own, or try to watch the video one more time. Try to write the strategies the way that you understand them, the way that make more sense to you. And that will provide a lot more understanding. And now that we are at the beginning of proving trig identities, you're also discovering your own methods and your own little tricks on how to get to the answer a little bit faster. So write them on the side of the paper, and you will see that the more you practice, the fewer notes you will have to write. It works a little bit like learning a new language. So the more words you learn consistently, then the fewer you will have as you make progress. So we're going to move on to our next example here. So you see that on the left side, we have one fraction and then another fraction, so two of them. The right side has only one fraction. So because I have two bigger terms in here, this time I decided to go for the left side first. So left side is equal to 1 over sine squared plus 1 over cosine squared. And at the end of the simplification process, I am hoping and dreaming to get this denominator here together. And I want to have only one fraction. So these are the things. This is how I can interpret what I want to get. So since we're trying to get a single fraction, then I must think, maybe since I have two fractions and I want to get to one fraction, why not combine these two? And it can feel as a daunting process to combine two trig terms, but remember, these are just algebraic expressions that contain trig terms. So when it comes to simplifying them as algebraic expressions, just basically use the same rules that we use in simplifying any algebraic expression, which means that if we want to add two fractions, you have to find the lowest common denominator. And in this case, because denominators are completely different and they have nothing in common, then you're going to say that the lowest common is the product of the two. Sine squared times cos squared, which means that, again, we're going to have to write 1 over sine squared, so the denominator of sine squared, as sine squared times cosine squared. So we'll multiply this by cos squared, and we won't forget to multiply the numerator by cosine squared as well, because we need to maintain the identity. Now, we have to work with the other term, 1 over cosine squared x, and this term needs a sine, or this denominator needs a sine squared. So you multiply by sine squared over sine squared. And let's see what we have cooked here. So the first fraction will have 1 multiplied by cosine squared. That's simply cosine squared. Denominator is sine squared multiplied by cos squared. The other fraction has 1 times sine squared, so that is sine squared x. The denominator is again cos squared sine squared, sine squared cos squared, same thing. So we're going to write them in the same order so that we can see the resemblance. And aren't you happy to see that sine squared and cos squared have surfaced to the denominator, right? So the next thing you can think of is bring them together. Now they have the same denominators, and that's the reason why we make them with the same denominators, right? So we're going to write them as a single fraction with the same denominator, sine squared and cos squared. And numerator will have cosine squared x and sine squared x. Now take a hard look at this expression and think, where have we seen these two together? And you're thinking in the one and the only Pythagorean identity for the primary ratios, and that would be exactly equal to 1. And we're going to say that is 1 over sine squared times cosine squared. And voila, we're going to say that the left side equals the right side, and we have proved this identity. So we'll continue with more identities in the next section of this video. And I hope you found these instructions useful, and I hope you enjoy proving trig identities. They are a little bit like puzzles. They're quite interesting. They can be frustrating, but let's try to find the beauty in it. And thank you for learning with me. Bye for now.